All right. Good morning, everyone. Final session before lunch, I believe. So I'll try it and end it on time. Okay, we got three groups. We got the two groups of people who are here for the presentation, and you're all here for me. Awesome. All right, before we get started with the actual talk, I just want to see a show of hands. Who here works in consultancy? Okay. And are you doing legacy modernizations at your customers then? Yeah. Who here works at a company with software over 10 years old? Nice. Those are the people I need right here. Perfect. On this image, you can clearly see a bridge that has been standing for decades. It's been around for 10, 20, maybe 30 years. It does its job. Cars go over it every day. Hundreds and hundreds of cars. Bridge is solid, it's trustworthy, it's everything you want of a bridge. But cracks are showing. And maybe one day, this bridge will stop working as expected and it will collapse, stopping lives in their paths. The same thing happens within our companies. We have bridges like this as well, but ours are made of software, not bricks. And when our software fails, that stops, well, maybe not necessarily lives, although sometimes, but that will cost us a lot of money, will cost us a lot of business. Somewhere in most organizations is a piece of software that is very quietly celebrating its 20th birthday. Just chugging along, making sure payrolls get calculated, people get their wages, business is rolling, the shop floor is moving, everything is working. This small computer in a very fancy data center is making all of this happen. Sounds familiar? We all have one of those. And if there's this computer that no one remembers what it does, then there's the scream test. You shut it off and you listen to who starts to scream. Then you know whose computer it is. Now, most days, these things just chug along happily until the day it stops working. And then what? Who still remembers how this software works? Who knows where the code is? All stuff like this. Those are the hidden risks within a lot of companies. Now, companies these days, no matter what sector you're in, almost every company relies really heavily on software. And if that software fails, then we lose business, we lose trust. And winning that trust back with our customers takes a lot of time and a lot of money. So the stakes to keep our software running are really high. Downtime is loss of revenue. Downtime is loss of trust. And both of those will cost you money, and you have to win that back. So it's really important to keep your software running, to keep it up to date, to make sure that the software stack that you're running on is supported by the vendor, to have security updates, and so on, and so on, and so on. Now, let's say you want to modernize an old application. Which road do you take? You can either go to the left side and rebuild everything from scratch, which is a really high impact on budget, on change management, and on timing-wise. That this, well, you don't rebuild everything in 2 weeks, right? No matter how many developers you put on there. Or will you evolve what you have? Keep the existing functionality, keep the existing code base, and just do a technical upgrade of the whatever framework you're running on. Those are kind of the options that you have. And as always, within software development, the road that you take will depend. It depends on a lot of things. It depends on the budget that you have. It depends on your application architecture. Is it even feasible to do a technical upgrade with the software that you have? Depends on the company culture. Is the software development culture within the company strong enough to carry an upgrade like this? Or do you need to go search for consultancy to help you with this? What's the timeline? Ask the business what the timeline is. Their answer is always yesterday. But if you look at this from a realistic point of view, doing a modernization of a legacy system like this will take years. if you want the full functionality. If you're doing it in the most complete way possible, then you're looking at years. Now, within this session, within this hour, I will talk about modernization things that we did, and I will be using an example. This was the old application. We turned this into this. This is just a use case that I'm using. What it's doing is not that important. We'll get into it. This is still going on. We're in year 2 of development of 3 years. Project of 3 million euros to modernize old stuff. This one, the old application, is 30 years old. It has been evolved a couple of times. So this will be the example throughout the talk. We had a lot of lessons learned with this one, so it's a great example. But before we dive further into it, hi everyone, my name is Nico. It's really nice to meet you all, to have you all here. I'm a .NET architect at a consultancy company in Belgium, where I do stuff like this. I modernize legacy applications. I really like doing that. It's a lot of fun. I really like it because it's not only the technical part, but I also need, as an architect, I need to talk to the business. I need to explain the really deep, technical, complex stuff in a language that they will understand. And that's something I really like to do. So that's why I do that. I speak at conferences like this. And if you want to follow me, I'm on Blue Sky. There's my handle. You can find me on LinkedIn as well. But that's about the only social networks where I'm active. So give me a follow. If you have any questions after this talk, you can come find me in the hallways, or you can reach out through social media afterwards. I'll be happy to help. With that, what are we really working with? We have applications that are between 10 and 30 plus years old within our businesses. Those applications were built for the constraints of their time. At the time that they were built, most likely they were really good applications, like really well designed, well architectured, built by people who know their stuff back then. Times have evolved, so have risks. The hardware limits of that time are no longer there, but in code we were working with limited memory, limited bandwidth, and so on and so on. User bases were smaller because 30 years ago, software was not that important yet as it is today. So our software was designed to handle 15, 20 concurrent users, but now we have 200 or 300 concurrent users, which is slowing the system down. And then over all those decades, small bugs show up. Can you fix this? And while you're at it, can you add an extra button there that does this? Oh, and then there's another fix there. And oh, this label has the wrong name. 1 day later, why did you change the name on the label? Someone else comes in. And you're just bolting on patch and layer after layer after layer. Functionality creeps in that is never documented. And in the end, no one remembers what the whole application is doing. And from an operational point of view, we are risking outages, we are risking security vulnerabilities, data leaks, they happen all the time. And integrations with external systems are becoming very fragile because those external systems, they might have evolved while you are still there on your old system. From a strategic point of view, your application won't scale because it was not built in an era that had scaling options. Scaling back then was, let's switch the server off, put in some more memory, switch it back on. We've just scaled our system. Find people. Where do you find Visual Basic 4 developers? Where do you find COBOL developers? If you can find them, these people are expensive. So that is also an issue. And your time to market slows down because you have to find the people, you have to write the code, you have to test the code, and so on and so on. Business as usual, the maintenance culture trap. This is what a lot of companies do. This is the as-needed fixes. We only fix stuff once it breaks. These days, when building modern software, we have our end-to-end tests, we have our integration tests, unit tests, a whole test suite, we have QA engineers, as we do in every single project we do, right? Right? No. We should have those people, but, well. So now we just wait until stuff breaks, and then we fix it, straight into production, every single time. And then often, the knowledge of this application, of this software, is captured within 1 or 2 people. And these people often know that their knowledge of building software is not up to date. So what they do is they start guarding their own job. This is my knowledge. I'm not sharing it with you, because otherwise I will be out of a job. The example that I'm using in this slide, or in this presentation, had a person like that, who happened to have the same first name as me. It was not me. So what he did was, he kept all the knowledge of the system within him. He was an internal developer at the company. We sent in a couple of consultants to just help with developing the application. This was before the modernization trajectory. And they would need, there was no Scrum board, there was no Sprint board or Agile, anything. Those 2 consultants will need to go to him and ask, what's the next thing you want me to do? And he would tell them, that button needs to be moved, that label needs to be changed. All the easy, boring stuff, that went to the consultants. All the functionally interesting stuff, he kept to himself, because he was the only one who knew how the system worked, and he kept it that way. As soon as he left the company, a week later, we were sitting at the table discussing modernization options. He stopped this from happening for years. Now, with business as usual, every single patch that you do, every workaround that you create to work around an issue or a bug, increases your technical depth and your long-term costs in maintenance. And often, these applications are part of a whole process within a company. And these older legacy applications, at one point, they become a single point of failure. An example of this is Rogers Communications in Canada. Rogers is an internet provider in Canada, obviously. And they had an outage in 2022. Internet went down for their customers, for all of them. Payment systems no longer worked. Hospitals couldn't access patient records. 911 calls couldn't get through, because this was not only the internet that went down, this was also telephone lines. 12 million people were impacted by this failure. Oh, that was too fast. At least 1 death was tied to this, because they weren't able to reach 911 fast enough. What was the issue? There was a legacy router that couldn't handle the new software update and just crashed. And that just had a domino effect on the entire network, and everything just went down. 1 legacy system in the entire chain impacted 12 million people. This is a very extreme example, I know, but it shows you what one small weak link in the chain can cause. Now, your maintenance costs will go up for an application year after year. In the early years, when an application goes into production, it's relatively cheap to maintain. The software is new, the knowledge is there, the framework that's built on is modern, gets its updates, you get CVEs, you fix the vulnerabilities, you push a new version, everything is running smooth. But over years, the longer that your application remains in production, the higher the cost gets, unless you keep modernizing and updating your system. In the end, modernization is not optional. It's overdue. This is the whole spectrum of modernization options as we have defined them within our company. So you can either just stay where you are, business as usual, and just fix it when needed. That's the top option, the status quo, the patching. Big advantage there is there's a low cost. Things just keep running, minimal disruption, low cost, immediate cost, not long term. The trade-off is your tech debt keeps growing and you are risking major outages somewhere down the line. Second option is a targeted modernization, in which you say, we got specific pain points in our system, we are upgrading those. Either just pull the functionality out, put it into a new application, for example, something that can scale. Your return on investment is focused on one particular part of your application, something that you can focus on. Easier to resource because the people that are already there keep the application running and someone else can build a new system. But your legacy bottleneck remains. The old thing is still there. You just took something out of it. Then there's the hybrid approach, in which you will start to build a new platform, keep the old platform doing its core business, and just have them interact with each other. There's a balance there in risk and reward. That's kinda nice. You can deliver your new software with increments, just piece by piece. But you have an integration complexity. Old system, new system need to be integrated. They need to talk to each other. They need to share data. They need to make sure that all the data is cleaned up and valid. So the full benefit of a hybrid approach is way slower. Now, if you go for a full modernization, then you are just replacing your key legacy platform, but you're phasing it out. You're taking a part of it, replacing it into a new system, go to the second part, and so on and so on and so on, until you have full modernization, full new system. Long term, this is a very good system to have, a very good way to modernize your system. You are aligning with modern standards. You are building the old thing without disrupting the new. You're building the new thing without disrupting the old thing. Your upfront costs, though, are higher because it takes a while before you actually get the results from this, because the thing needs to be built. And you need change management. You have users, people that run your business, that work with this software 8 hours a day, 40 hours a week, at least. And all of a sudden, you're giving them the same thing, but it looks different. And the buttons aren't where they're supposed to be. And what's with these colors? And this used to be way handier. Who moved my cheese? Right? So you need change management there. And then you can go for the big bang. You just redesign the whole thing. New tech stack, new application, throw the old one out, put the new one in place, done. This is a very future-proof way of working, but has a very large investment and a very large impact. I've never seen someone took this approach. If you have, I'd be very interested to talk about that, to see how that went. We went with the full modernization thing where we just took pieces out and rebuilt it into the new system, had them interact with each other. Now, whatever option you choose, as you go down the table, or in this case, it's the same things, but on a scale, the more you go towards the warm colors, towards the yellow, the larger your investment gets, but the higher your impact gets as well. High impact, high rewards, because you're very future-proof in this way. Now, about the case study. The application is called Job Manager. The customer is a R&D center that specializes in steel, in creating and inventing new steel alloys. That's what they do. That's their business. This application does everything. When I say everything, I mean everything. It handles stock management. Large sheets of metal plates are in stock. Those are taken out. Those are cut up into strips. Those strips become new pieces in stock. So one part comes out, 20 new parts go in stock. Those get turned into an alloy with some other material. Again, new stock item, results of that research gets inputted into Job Manager. So far, so good. I mean, what are you saying? That everything, this application does everything, it just runs the business, right? Right. It also does timesheets, meeting room bookings, registering visitors in the company. It does everything. Every single person in this company, from the researchers until the reception desk, everyone uses this application full time for everything. It started in VB4, back somewhere in the 80s, I guess. Then they modernized into VB6. Then they modernized into VB.NET WinForms. And this was all that one person that kept all the knowledge with him. He was the one that did the VB6 to VB.NET. Why VB? Because he knew VB. He didn't know C#. So that's why VB. So VB.NET WinForms, they eventually migrated up until .NET 4.5, I believe. Could be 4.2, it doesn't matter. 4.x. And that's where they stayed for a long, long time, until that one person left the company. And then we realized that business wants to modernize. So we went to sit at the table with them. And this was the timeline. This is a really big project, very big application, does a ton of things. So we thought we need to do a pre-study. We need to understand this application better before we can give them an offer to modernize the thing. We need to know what the thing does. So we put in an offer for a pre-study. This was about 25, 30K, I believe, off the top of my head, just to get to know the thing. Basically, paid pre-sales. Analyze the whole thing, technical, functional, make sure we can give them an offer that we can actually do it for. After the pre-study, we made them the offer, they accepted, we started implementing, and we went into production. Currently, about, well, 70% of the application is done and is running in production and synchronizing with the old system. We started with the pre-study, which was a ton of workshops. We needed to capture the as-is situation. What do we have now? What does it do? What documentation is there? Which was interesting, because the most recent update in the documentation was 15 years old. Most recent update in the application was not 15 years old. Capture the as-is situation. Capture their needs. What do you want to do with the new modernization? Do you just want to have a technical upgrade? Keep it in WinForms? What do you want? Set priorities, set trade-offs, because there will always be trade-offs, always. And then select the path. Remember the two paths in the beginning? Full modernization, upgrade the tech stack. We needed to decide there. Now, what did the application look like internally? As I've mentioned, stock management, task management, reporting. I'll get back to you about the custom actions. Timesheets, meeting room bookings, visitor registrations, every single thing. Coming back to the custom actions, that's a fun one. We were dealing here with researchers, really smart people. What did they invent? They invented a system where they could download an Excel template. They could put in custom VBA code in that Excel with data coming from their research. They would upload that into the system, and the system would have new rules created by the users through Excel macros. Flexibility-wise, awesome for them. From a technical point of view, I was impressed that they made this work. From a modernization point of view, they will never want to give this up, because giving up flexibility is a struggle with every modernization, always. People are used to having flexibility, they will not give it up. Compare this to the remote working that we have. People that can work from home every single day and are then forced back 3 days a week, they will not be happy. Same thing, flexibility being taken away. From a technical point of view, we are looking at WinForms with .NET 4.x, SQL Server with stored procedures, which contains hard-coded usernames. Interesting fact that we discovered. The whole system, every single functionality, was developed as a stored procedure. The only thing the WinForms application does is call into an ASMX web service. That web service triggers a stored procedure. And that stored procedure contains the functionality, always. Now, specific functionalities are only allowed to be used by specific type of users, because they have the permissions to do that, right? Now, role-based permissions are not a thing here. What they did is, in the store procedures, they would hard code the username of the people that were allowed to do it. Those people went on holiday. Their backups, that was a change request. To have the backups usernames in the store procedures to change that. That was a change request to the dev team. Someone left the company, well, we need to check what store procedures we need to change to make sure that they will still run. So that was obviously something we wanted to change. The data model was very, very complex. We gotten a PDF of the data model. I think if you want to print it readable, you need like a plotter printer. It was that big. It was never normalized, or it was just built upon and built upon and built upon. They, as I've mentioned, had an ASMX web service, which is WCF before WCF was a thing. So SOAP services. There was a print service, which ran on a server because they needed to be able to print on network-based printers. So that was through a service. And then there was a file server which contained about 3 terabytes of files. That's what we found out after a bunch of workshops. VB.NET developers in-house. 2 of them were consultants from us, but there was not a lot of C# knowledge there because they've been doing VB since forever. No agile things. 1 person had all the knowledge. We went over this. But no one in the dev team had any knowledge about .NET Core or higher. They knew .NET 4 in VB, and they were really good at it. But that's what they knew. So we went to work with them. We did functional workshops, technical workshops, we did UX workshops. UX, user experience, not to be compared with UI. That's design, that's something else. Architectural workshops. That was me, I did those. That was meant to gather requirements, documentation, schematics, what's there? What is the as-is situation from an architectural point of view? What integrations are we missing? What didn't we see? Turned out that wasn't too bad. I think we saw them all. What is going to be the to-be situation? And this was an interesting one. They came to us and they said, we want this thing to be in the cloud. Sure, let's put WinForms in the cloud. And this needs to happen fast because our servers are starting to fail and we need to invest. So as a quick solution, we just put the file, the ASMX web service and the database, we just put it in VMs in Azure. That saved them some money that they later lost because VMs are really expensive. But the file service, the print service, that needed to stay on-prem. So that was the first step of going into the cloud. Oh, by the way, they told us, there are other R&D centers like us. They're not really competition, but a little. And we want to sell the new software to them in a license. So this thing needs to be multi-tenant and needs to support selling licenses. So obviously, it will need to scale pretty good as well. That was a really interesting requirement. as a technical guy, I just went like, ooh, looking forward to building this. What will the eventual team look like? Who is going to build the thing once we are done with the offer? In the end, the team consisted of an architect, an application architect, a cloud architect, 3 developers, functional analysts, QA, project manager, of course, and 2 UX people. Big team, big project. What existing knowledge is there? So the 3 developers I've mentioned, 2 of them are the 2 people who are at the customer since years, because they are the ones who will have to maintain the new system once it's fully live. So we involve them in the development process, so they get to learn the new project, the new software. Architecture styles, well, they only knew one basically, and that's just simple client server. So there was a lot of training to do. CI/CD was not in place. That needed to be set up. Cloud or not cloud, that was determined pretty fast. And then we came to the non-functional requirements. This is a big list. And these are all things you need to check for with your customer. What's important? What has priority? Almost at the end. There we are. These are often called the illities because a lot of them end in illity. If you search online for a list of illities, you will find this list. And these are all things you have to check with your business owner, with your product owner. Like, how available does your application need to be? And most likely, they will go yes. Okay. How performant does it need to be? Yes. Okay. How secure? Yes. Yes. So don't ask these questions directly, because you will always get that answer. Everything is important, but that's not how it works. These list of requirements need to be prioritized depending on your business needs, non-functional needs. Because it's often a trade-off between several things. High performance might suffer from high security because you have a lot of round trips to identity systems. Trade-offs like that. So have a conversation with your business owner and try to figure out where his priorities are without actually naming them. Because if you use these terms directly, they will all be as equally important, and that's not how it works. So just have the conversation, talk to them. This was a long conversation. This took a full day. Just talking, taking notes. And then another day to go over the notes and start listing priorities. So take your time for this. This is really important. From a functional point of view, you are rebuilding an old system. A company is spending a lot of money to rebuild an old system. This is the perfect time to ask the question, do you need all this functionality? Everything that this application does, do we really need a job manager to handle visitor registrations? To book meeting rooms? There are other systems for that, right? This is the moment where you can ask that question. And that's what we did. We replaced meeting room management with Outlook. That does a perfect job of managing meeting rooms. Visitor registrations were also removed and replaced with dedicated software that specializes in this thing. And buying a license for this stuff, Outlook, they already had Outlook. We just configured Exchange to also include their meeting rooms. Right? So no, not really an extra cost. Buying the license for the visitor registration software was way cheaper than building that functionality again in the new system, obviously. So that was a quick win. And so on and so on. Not only should you ask the question, do we need that functionality? But are our processes as lean as they can be? What are the processes that we have in the application? Do they match with the process that we have in the company? Is the business process the same as the technical process? If not, let's align. Is this really the most optimal way to do things? If not, let's optimize. So we had a functional analyst go all the way in. She discovered everything, like all the undocumented features. She spent tons of workshops there. She discovered everything. There's a mirror board that takes a long time to load because it's so huge that has all the functionalities. And then they went to work with the processes, and they actually optimized the way that the business works, the way the company works got optimized because the processes got optimized. If you're building on top of an existing software for too long, then in the end, there's always a turning point where you will start to adjust the process of your business to fit into the software. But it should be the other way around. Your software should be modeled towards your business process. So this is, again, the perfect time to take a look at that. In the end, we narrowed Job Manager down from 7 modules to 3. Less than half. Then the UX workshops began. I have 2 close friends who are really good at being UX experts. They captured pain points in the current application. Like they take end users, people that use the application, and they will go and use the new application as well because reception desk didn't need it anymore, so they were out. Put them around the table and just went, what is slowing you down in the current application? What makes you go, "Urgh," if you use the application? And they captured all those pain points just to make sure that we don't repeat them in a new application. A new application in the end should be an improvement, not a status quo. Processes got optimized. I already mentioned that our functional analysts did a really good job at capturing them all together with the UX people, because this is a team. This is not just silos of people doing workshops. Everyone got together and shared findings. Processes really got optimized. And the UI got, as I mentioned, was shaped around the process, not the other way around. UX is still involved in the project today. They did their designs, but they are there to validate the implementation and to capture feedback from the pilot users, because they will often say, on the design, this looked really good, but when we actually use it, turns out that we are holding a tablet with the application open, and your button is on the top left, but when I'm holding the tablet, it should be on the bottom left, because that's where my thumb is, and then they will move the button. Things like this, these small details that improve your user experience, they will capture this and change the designs. Once something is delivered, the dev team says this is done, UX will also validate that they implemented the design, because developers aren't always very nice, especially when it comes to following UX designs. That's also something that you really need to watch out for if you're doing this. Developers or developer team that has never worked with UX designs before, there's a learning curve there. And often developers will go, yeah, what UX designed there, that's not possible. And that's not possible doesn't exist in software. Everything is possible. It will cost way too much money for what it's worth. That's something else. That we can have a discussion about, but it's not possible. No, everything's possible. Create a custom component. Whatever. It might take you 3 weeks, but if it's important for business, then take you 3 weeks. But have your developers and UX work together as a team. There will be struggles there. They will fight each other. UX is making things too complicated. The devs aren't listening to us, and so on and so on and so on. Make sure you capture those in time and prevent that from escalating further. Now, UX is often one of those first things that get kicked out because budget constraints. Please, please, please don't do that. If you take one thing away from today, Make it be this. Skipping out on UX is not cost saving. It's a return on frustration on your end users. Because you are not capturing and solving those frustrations, those pain points. You need these people. This is a timeline of our phased approach as we took it. I've mentioned the first orange block, lift and shift. We took their API in their database, put it in VMs, up into the cloud. We created a new cloud environment for them. We brought new tooling in place, pipelines. We introduced agile work into the team, had an agile coach there to teach them the ways. Brought new toolings into place, developed the new modules. Once a module was released, remember, 3 modules left, put them into production, keep the old and the new database in sync. That was kind of the phased approach we took. Worked rather well. The interesting thing was, as soon as development started, or was about to start, they came to us like, oh, by the way, remember that licensing requirement and multi-tenancy that we had? We're not going to do that anymore. It's just going to be for us. This was development day -1, so the day before we would start development. So yeah, that's why you need to keep your customer close, because they will change their minds. Now, remember the printer and file service that we had? We were thinking, like, how can we put 3 terabytes of files that needed to be searchable, like content-wise searchable? How can we put this into the cloud? And we've consulted with SharePoint consultants that we have, because this is something that SharePoint does. And he just went, 3 terabytes, don't do it. Keep it on-prem, which is what we did. File service, still on-prem. Why? I don't know. He was the SharePoint specialist. I just trusted him. Printing service, same thing. The printers are on the local network. They need to be reachable from there, so local print service. But we did set up a site-to-site VPN from the cloud to the on-prem environment so that we could reach them from the new cloud-based applications. Now, trade-offs. And this is the thing with a modernization. This is not a greenfield project. Yes, we did file new projects, but we did have to keep a bunch of the old stuff there. So we kept the database. The old database was kept, but it was optimized. We took a look at the data model. We cleaned it up where possible without being too invasive into it. Got rid of all the store procedures, because we don't do that anymore. So we kept the database, but we cloned it. So the old original database in all its glory is still there. We took a copy of it, optimized that, and there's a sync going on between the two to keep the old and new system in sync. Parts of the application are still on-prem, as I've mentioned. And those were actually the biggest trade-offs that we had to do. Not too bad. From an architectural point of view, after the workshop, I've given them a couple of options. This was the first one, just your good old monolith. Now, we have already decided that the front end was going to be web-based. No longer WinForms, WPF, or whatnot, web-based front end. That was set upon. So first option there was, we will build you a front end, we will build you a REST service instead of ASMX, connect to the database, have some identity in between, done. Monolith. Modular monolith. If you want to learn more about that, Jimmy Bogart's got a great talk about the modular monolith. Go check that out. But in the end, it means that if this thing would grow and needed parts to be scalable, you could just explode it into services and make those scalable. So that was option 1. Then option 2 was the service-oriented architecture, where every module would have its own REST service. And there are 4 here on the schematic, where there were 3 in the actual product. That's because this was designed before we narrowed it down into 3 modules. So a bunch of services, an application gateway in front of them, and then a web front end in front of that gateway with one single database. That was option 2. Option 3, microservices. Every service, its own database, multiple services, message bus to have communication between them. Your basic microservices architecture. And the final one was micro frontends. And this was especially interesting when we were still talking about the licensing thing, because then every customer that would get a license could pick what modules he wanted licensed. And you would just open up those specific front ends to that customer. So that's why this was in there. In the end, they went with this. Because this was the best trade-off cost-wise and modernization-wise. We keep the database, modernize it, put a bunch of services in front, have your gateway, have your front end. During this whole project, this whole path, we ran into a lot of challenges on a lot of different sides. So challenges that we ran into with our stakeholders and our business was mostly about resistance. End user inertia you will always run into. But we've always done it this way. Why change it now? Sound familiar? Fear of change. But if we need to learn this new way of working, then our productivity will go down. Yes, that will happen. Short term. Once you get used to the new way of working, productivity will reach an all-time high if you've done your job correctly. Loss aversion. But this one feature that you're kicking out of the project, that was my idea. I made this happen and now it's gone. Stuff like that. You will run into that. Especially in an environment like this where end users can just walk up to the developers and say, I want a button that does this. And the button will appear in the next 2 weeks. Then there's team dynamics, politics, job protection. The guy that left the company that kept all the knowledge with him, those people you will run into all the time. Territorial ownership. This is my application. I make the rules here. Those people. Skill gaps. If you need to take devs along that will, in the end, maintain the system, you will need to train those people. And they will need to learn on the job. That will take time. That will take money. That will take patience out of the other people in the team. Definitely a challenge. From a technical and a process drag point of view, undocumented features that show up during development. We've had those. Features that just appear somewhere because someone went to talk to the dev team, and there's, if you go to help about, there's a small picture, and if you click on the nose 5 times, then a new feature will pop up. Something like that. Integration entanglement. Other systems that you integrate with that are maybe legacy themselves, those might break as well. Integrations are often other systems with data that you absolutely need in order for your application to do its job. So you need to make sure that those integrations are still there. Often, you do not own or maintain those applications. If you do, then that's fine. That's your next modernization track, and the money keeps rolling in as a consultancy company. But often, you don't own them, and then hopefully they have good documentation. Lack of test coverage. I don't need to explain this one, I think. That's a given in every project I've done so far. Timeline, delivery pressures. Parallel priorities. Your team is still supporting the business as usual, the old application, while building the new one. and then there is a quick hotfix in production of the old system and everything breaks. So development of the new system grinds to a halt because this has priority all of a sudden. And then at the end of the sprint, you have to explain why your features weren't delivered. What happened? I thought we made estimates. Aren't your story points worth anything? Scope creep. Oh, by the way, as long as we're building this feature, we might as well add this one as well. I know, we haven't analyzed it, but it'll be fine. It's just an hour more of work. 3 days later. Unrealistic deadlines. And this is often business that's pushing development. Like, we want this now. It's only a button that does a calculation. Yeah, that's right, but the calculation is 300 lines of logic. How hard can it be? You just click the button and the result pops up. Can't be that hard, right? Unrealistic expectations. Now, after our case study, or where we're at right now, that's right. I said we were doing the service-oriented architecture, right? That was the plan, but in the end, we ended up building the monolith. So we are building a monolith API with a copy of the existing database. The dev team, our consultants, plus the in-house developers. Development will take about 3 years. We're 2 years in now. Everything is looking good. I'm not involved in the development itself. I just did the pre-study, and I'm following along because, well, they're my direct colleagues that are doing this. So it's interesting to keep an eye on it. 3 million euros to do this. That's 1 million per module. It's not that equally divided, but just to give you an idea, which would mean that we saved them 4 million by cutting back features from 7 modules to 3. And all the challenges I've just mentioned, we've run into every single one of those. Every single one. For now, the Excel thing is not in there. Once V1, the MVP, is fully delivered, that's when they expect us to build the Excel macro thing, because they will not give up that flexibility. Believe me, we have tried. We have tried so hard. They will not give it up. They want it back. So, yeah. That's waiting for us after module 3 is delivered. License requirement was dropped early. Well, early, not early enough. But those things change. Requirements change. And the thing here is, we did a pre-study. We handed them the offer. They said, sure, we'll agree to your 3 million euro offer, but we can't budget it in this fiscal year anymore. Fiscal starts in January, it was March. We'll do it next year. But that's a whole year of technological advancements, of requirements that might change, of potentially new features that creep into the old application. And in around November, we went back to them saying like, okay, you're probably doing your budget rounds. Are we doing this? They said yes. We are doing this. It's budgeted, or it's included in the budget proposal. We'll see what happens. In January, they came back. We're doing this, but we can only spend 1 million a year. So yeah, team of 9 people. Money flows pretty fast. So that's why it's taking us 3 years. This could be done sooner, but not that much. But it's mostly because of budgets. From a technological point of view, the backend is ASP.NET Web API. We have a Blazor WebAssembly in the front end, because these are all .NET developers. The in-house devs needed to upskill from VB to C#. To add JavaScript or TypeScript to that would increase the pressure on them by a lot. By being able to use their existing and evolving .NET skills in the front end, that took away a lot of stress on them. That really helped us. We are using the BFF pattern, the backend for front end. When we started discussing about this, BFF was not that well known yet. That was not on the table. This was the team that is actually executing the project that says, BFF would be a good fit for this. We are using that. And those are the people you need, people that can look further than what's on the paper, that can say, maybe it's a good idea to do this. And then they discuss, and then they implement. Security is Azure Entra ID, and everything is hosted on Azure Web Apps with an Azure SQL database. So we transformed the SQL database to an Azure SQL database. Print server is still on-prem, file service is still on-prem. There's sounds going off. All right, just to wrap up, we got time. Start thinking about modernizing your systems early, especially your business-critical systems. Even though it's a small link in the chain of your business process, think about modernizing these things early, because it's a process. It takes a long time if you want to do it right. You want to go for technical rewrites, you want to go for an upgrade, make those trade-offs, like what's it going to cost? What's it worth to us? Go through all the different steps, do the workshops, do them internally, sit together with all the different stakeholders, all of them, from the product owner to the end user. Because those end users, the people that will actually go and use your application, those are your most important stakeholders. They are using your application to do their job. And if your application is standing in the way of them, doing their job in the most performant way that they can, most effective way, you will get into trouble with them. So listen to them, listen to what their pain points are. Collect all the documentation, write the missing documentation, even for the old system. Write it, complete the documentation. I know it's boring. I don't like writing documentation. We got LLMs that are really great at doing that now. Use them for it. Find the right skills. If you can't hire them internally, search for consultants. Find the right skills, find the right people, train your people that will, in the end, maintain the product. With that, thank you so much for being here. Have a nice rest of the day, and I'll see you soon. Thank you.